We press play on videos probably dozens of times a day. But have you ever stopped to think about what's actually happening behind the screen? Well, today we're going to pull back the curtain and demystify the incredible tech that brings everything from huge Hollywood movies to your favorite vlogs right to your device. So let's dive in. It's a fantastic question, right? You've got this massive, beautiful, crystal clear 4K movie, but somehow it streams to your TV or your phone almost instantly. It really does feel like magic, but I promise you it's not. It's actually a brilliant system of really clever tricks and engineering, and that's exactly what we're going to unpack today. All right, to really get this, we've got to start at square one. Before we can even talk about streaming or 4K or anything like that, we need to understand what digital video fundamentally is. And it turns out the whole thing, it's all a very convincing illusion. And that's the core secret right there. A video isn't one continuous moving picture. Nope, it's basically a high-tech flipbook, just a whole series of still photos or frames shown so fast that our brains stitch them together to create what we perceive as fluid movement. This shows it perfectly. Each one of these is a single static picture. But when you flash them in front of our eyes at, say, 24 times a second, or even faster, your brain just can't process them as individual pictures anymore. It blends them all together, and instead of seeing a slideshow, we see a car smoothly jumping over a ramp. Wild, right? So, if video is just a fancy flipbook, how do we control how good that flipbook looks? Well, it really comes down to two main dials that we can turn up or down to adjust the quality and the whole feel of any video. And those two dials are frame rate and resolution. Here's a simple way to think about it. Frame rate is the speed of the flipbook, how fast you're flipping the pages. And resolution is the detail on each one of those pages. Let's break them down. Each of these frame rates gives you a totally different vibe. 24 frames per second? That's your classic, dreamy, cinematic motion we all associate with the movies. 30 FPS is a little bit smoother, which is why it's the standard for TV. But when you jump up to 60 frames per second or even higher, you get that hyper-smooth, super realistic look that is absolutely essential for things like fast-action sports or responsive video games. Okay, now for that other dial, resolution. This is all about detail. How crisp is the picture? 480p is what we used to call standard definition. It's fine for, a tiny old phone screen. 1080p or Full HD, that's pretty much the workhorse for modern video. But 4K? Wow. That offers 4 times the detail of 1080p, giving you that incredibly sharp and immersive picture you want on a big screen. Okay, so we've got high-resolution pictures, and we're showing a lot of them every single second. This creates a huge problem. Raw video files are just astronomically large. And that is no exaggeration. A single minute taking up gigabytes of data. Seriously, imagine trying to stream a 2-hour movie like that. It would be literally impossible. Your internet connection would just give up. So this is why we absolutely need a way to make these files drastically smaller without completely wrecking the quality. The solution is video compression. You can think of it as super smart digital packing. Clever algorithms look at one frame, then they look at the very next one, and instead of saving all the information for both frames, they just save the differences. If a character is talking but the background isn't changing, why save that background twice? By removing all this redundant data, it shrinks the file size down to a tiny fraction of the original, all while trying to keep the picture looking amazing. Now, once that video is all packed up and compressed, it needs to be put into a container, and that's what these formats are. MP4, that's the universal one you see everywhere, YouTube, your phone, you name it. MOV is a really high-quality format that video editors often use. And MKV is super popular for HD movies because it can hold tons of extras, like multiple audio tracks and subtitles, all in one neat file. And the results are, they're staggering. The power of modern compression comes from these brilliant little algorithms called codecs. Using an efficient codec, you can get a dramatic, almost unbelievable reduction in file size compared to older ways of doing things with very little noticeable loss in quality. This efficiency, this is the key that unlocked video streaming for the entire world. So we have our small compressed video file, awesome, but that's really only half the battle. How does it actually travel across the wild, unpredictable internet to play smoothly on your device? This is the final and maybe the coolest piece of the puzzle. This is where the real magic happens. It's a technology called adaptive streaming.
Instead of just sending you one giant file and hoping for the best, the streaming service has a super smart system that is constantly adapting to your specific situation in real time.
It's like this constant conversation happening in the background. The player on your device is always monitoring your internet connection. Is it fast right now? Great! It selects a high-quality chunk of video. But what if your connection suddenly gets worse? No problem. It immediately switches to a lower-quality version for the very next chunk. This whole process is what saves you from that dreaded buffering wheel. And this is how they get ready for it. When a video gets uploaded to a platform like YouTube, it's not just stored as one single file. Nope. It's automatically encoded into multiple different versions. Everything from a low-res version for a phone on a shaky connection, all the way up to a high bitrate 1080p version for a TV on a super fast fiber line. Your device just has to pick the right stream for that exact moment.
Okay, so let's bring all of this together. Let's see how all these technical concepts actually show up in the apps we use every single day.
You've definitely seen this menu on YouTube, right? Well, that little quality selector, that's your manual override for the whole adaptive streaming system. You're basically telling YouTube, hey, I know my connection is good, forget the auto setting and give me the full 1080p version. It's the exact same technology that platforms like Spotify use to deliver their video podcasts so smoothly. So what's the big takeaway here? Why does this all matter? Well, this whole system has completely revolutionized how we consume media. It gives us that smooth, buffer-free experience we just expect now. It saves bandwidth by not wasting a huge 4K file on a tiny phone screen. And maybe most importantly, it makes video accessible to everyone, everywhere, whether you're on a blazing fast connection or spotty mobile data. So the next time you're watching a video and you see the quality dip for just a second and then recover and look amazing again, you'll know exactly what's happening. You're not just watching a video, you're watching a complex adaptive system working perfectly just to bring it to you. So what else are you going to notice now that you know how it all works?